with the rational horizon questions?
सर एक क्वेश्चन था सर.
Okay, all right. बताओ बेटा.
सर थ्योरी का क्वेश्चन है सर. ये पास पेपर में था. व्हाट इज द कन्फर्मल प्रॉपर्टी ऑफ अ मर्केटर चार्ट यूज्ड फॉर?
मैंने आपको एक थ्योरी क्वेश्चंस का एक 2 पेज का डॉक्यूमेंट भेजा था.
यस सर, यस सर.
Just have a look at it. I have written the answer of this question. It is mentioned there.
ओके सर, ओके.
Okay, पेज नंबर 2 में आपको मिलेगा.
ओके सर, थैंक यू.
Okay. Okay. So shall we move on to presentation, beta? Rational horizon?
Yes, sir.
Okay. So let's set up. In this presentation, we are going to learn about the numerical which are based on rational horizon diagram. Now, before we go into the actual questions, some of the questions have the concept of local sidereal time. So let me first explain to you what is the meaning of local sidereal time, also known as LST. LST or local sidereal time is the westerly R angle of the Aries measured from observer's meridian. Let me show you with the help of a diagram. Let's make the diagram of the Earth looking from top of the North Pole. So if you look at the Earth from top of the North Pole would appear to be exactly in the center. This will be the North Pole, and the circumference which you see will be the equator. So we are looking at the Earth from top of the North Pole. Let's show the Greenwich meridian in this diagram. So by convention in these diagrams, we always show the Greenwich meridian pointing downwards. Now exactly opposite to it is the 180-degree meridian. Now let's assume our observer in this diagram. Let's assume the observer is at this particular location. We can now show the observer's meridian also. So this is the observer's meridian. Exactly opposite to this will be the inferior meridian of the observer. This is the inferior meridian of observer. Now let's assume that Aries was at this particular location. Now we can show the local sidereal time LST in this particular diagram. When you look from top of the North Pole in this way, then the westerly direction is the clockwise direction. The clockwise direction in this diagram represents the westerly direction. You can see this arrow showing the westerly direction to us. So now we know LST is the westerly R angle of the Aries measured from the observer's meridian. So we need to start or take our reference from the observer's meridian. From the observer's meridian, we need to go in the westerly direction, you see, westerly direction, and we need to go up to the Aries. So from the observer meridian, measuring the angle in the westerly direction up to the celestial meridian of Aries. This is what we call as LST, local sidereal time. Now this can be represented in angular units as well as in the units of time. In angular unit, it is represented in degrees. And if we want to convert it into the units of time, 360 degrees is equal to 24 hours. So this gives us a factor of 15. So when you measure this angle in degrees, you divide it by 15 and you will get the LST in the units of time also, hour, minutes and seconds. So this is the definition of local sidereal time. Westerly hour angle of Aries measured from the observer's meridian.
Now, beta, one important thing which you will see here is that this local sidereal time, when converted into angular units, degrees and minutes, will give you the LHA of Aries. You see, LHA of Aries is also the westerly hour angle of Aries observed or measured from the observer's meridian. So LST converted into angular units gives you the LHA of Aries. Any doubts in this, beta? Okay, great. Let's proceed ahead.
Let's now go into our first question based on the rational horizon diagram. The question says, during morning twilight, an unknown star bore south with a altitude of 40 degree 20 minutes. During evening twilight at LST, local sidereal time, 3 hours 34 minutes and 24 seconds, the same star bore north with a altitude of 13 degrees 08 minutes. Identify the star. Now, before we start solving this question, I would like to explain to you the basic concept or the basic procedure which we follow in all these celestial navigation based questions. Now, the basic thing to be done is, number one, draw the rational horizon diagram. Whenever you get such a question based on principles of navigation, you draw the rational horizon diagram. And in that rational horizon diagram, you try to fit in all the required information which is given to us. So whatever information is given, a particular celestial body, its bearing, its altitude, or any other information, we try to put in that particular diagram. Now, as we put all this information in the rational horizon diagram, the diagram itself tells us or leads us to the solution of the question. In most of the cases, the question can be solved using spherical trigonometry. You will have a PZX triangle formed, and you can use the spherical trigonometry cosine formula or Napier rule. One of them will be applicable in that triangle. And by applying these formula, you will be able to solve the question easily. So this is the basic concept which we use. Make the rational horizon diagram, put all the information what is given to us in the question, and we will get a lead from the diagram itself how the question needs to be solved. Either it will be a very simple calculation, just adding or subtracting some values, or it will be a solution of the PZX triangle using the cosine formula or the Napier rule. Now let's try to check this concept, whether the concept works or not in this particular question. Let's fit these things one by one. We will first make the rational horizon diagram. So you make a circle and you show these 4 points representing the directions: north, east, south, and west. NESW, these 4 points are shown. Now at the center of this circle, we have the zenith. So we can join N and S, we can join W and E. The point of intersection gives us the center of the circle, which is the zenith. So the center of this diagram represents the zenith of the observer. The circumference represents the rational horizon of the observer. Now let's try to put all the given information in this particular diagram. Now they have told us that during morning twilight, the star was bearing south. Now south bearing in this diagram is represented by this line ZS. ZS represents south bearing. The point S is on the rational horizon with altitude 0. The point Z is the zenith of the observer with altitude 90. So our star was bearing south. That means it has to be somewhere on this line ZS. So star bore south with a altitude of 40 degree 20 minutes. So our star, which is on line ZS, has a altitude of 40 degree 20 minutes. Now we know the radius of this diagram is 90 degrees because its center is zenith, the circumference is rational horizon. Every point on the rational horizon is 90 degrees away from the zenith. So the radius is 90 degrees and the altitude of the star is 40 degree 20 minutes. So that means it is 40 degree 20 minutes above the horizon. Now on this line ZS, S point represents the horizon. If you go 40 degree 20 minutes away from it, this is the location. 40 degree 20 minutes away from the horizon, this is the location where the star is. So we have shown the star's position at the time of morning twilight, and let's mark that position as X. Further, the question says during evening twilight at LST so and so, the same star bore north. So north bearing represented by Zn. The star had a altitude of 13 degrees 08 minutes. So it was 30 degrees 08 minutes from the horizon. Now N point represents the horizon here. So if we go 13 degrees 08 minutes above the horizon, this is where the star is at the time of evening twilight. Now we have the location of the star at the time of evening twilight as well as at the time of morning twilight. It is the same star. Now the same star can be at these two locations, that is X location in morning twilight and X dash location in evening twilight, only in one way. Its declination circle has to pass from both these locations. The star always remains on its declination circle. And there is only one way a circle can be drawn passing from these two positions. How can we draw a circle? The circle can be drawn in this particular way only. So this circle, which is passing from X and X dash, represents the declination circle of the star. Now we are aware that at the center of all declination circles is the pole. So let's mark off the center of this particular circle. The center will be north of Z because you see Sx distance is 4020, which is much greater as compared to Nx dash, which is only 13.08. So the circle is offset to the north. The center will be north of the zenith. And the center of the circle has to be the pole. We are aware that all the declination circles are centered at the pole. Now the star will be moving in this particular direction marked by these green arrows.
बोलो बेटा.
सर आपने ये पोल अभी जेड से ऊपर कैसे बनाया था? आपने अभी बोला ना, वो मिस हो गया था सर बीच में.
बेटा जो SX डिस्टेंस है that is 40-20.
डिग्री. हाँ जी, और ऊपर वाला 90 माइनस 40-50 हो गया. हाँ जी.
NX dash जो है that is 1308.
हाँ जी सर.
है ना? So you can easily see that this
X निकाल सकते हैं. हाँ जी.
is offset to the north side of the zenith.
अच्छा ठीक है सर. अच्छा ओके ठीक है, ऐसे ठीक है.
अगर ये दोनों डिस्टेंस सेम होते द सेंटर वुड बी एट द
तो सेंटर में ठीक है सर, ओके।
अगर ये ऊपर वाला डिस्टेंस बड़ा होता देन द सेंटर वुड बी साउथ ऑफ द जेनिथ दैट वे।
सर वो आगे की साइड झुका हुआ, नॉर्थ की साइड झुका हुआ, ठीक है सर।
राइट बेटा, राइट।
This is how the star will be moving. We can also show the equinoctial in this diagram. Equinoctial is 90° away from the pole. So you go 90° away from the pole, and this point is the Q point from where the equinoctial is passing. And equinoctial always passes from the west and east points. So this blue color line which you see in the diagram now represents the equinoctial WQE. Now the LHA Aries is obtained from the value of local sidereal time. As I told you, local sidereal time is the westerly R angle of Aries measured from the observer's meridian. And this is in the units of time, 3 hours, 34 minutes and 24 seconds. As I told you, we can easily convert it into angular units by multiplying by 15. So we multiply this LST 334.24 by 15 and we get a value of 53 degrees 36 minutes. So this 53 degrees 36 minutes is the westerly R angle of Aries measured from the observer's meridian. And this is the definition of LHA Aries. In fact, if LST is given to you, if you convert it into angular units, it gives you the LHA of Aries. LHA of Aries is the angle at the pole contained between the observer's meridian and the celestial meridian of Aries measured westwards. And this is exactly what LST is. So multiplying the LST by 15, we get the value of LHA Aries, which is 53 degree 36 minutes. Now let's show this value in our diagram here. The observer's meridian is represented by PZQS. This particular line represents the observer's meridian. Now LHA Aries is 5336. So from the observer's meridian, if I draw an angle of 53 degree 36 minute, this is where the meridian of Aries would be. So from the observer's meridian, we go in the westerly direction. You see, this is the westerly direction by 53 degree 36 minutes, and it gives us the celestial meridian of Aries. This is the location where Aries is going to be. Now you see, we can find out the westerly R angle between Aries and star X. Now when Aries was at this particular location at the time of evening twilight, the Aries was at this particular location and our star was at the location of X dash. So Aries is at this particular location, the celestial meridian of Aries represented by P Aries, and the star is on this particular celestial meridian, the celestial meridian of the star represented by Px dash n. Now we can easily measure this particular angle, the green color angle in the diagram. What is this green color angle? It is the angle at the pole contained between the celestial meridian of Aries and the celestial meridian of the star. And this is the definition of SHA. So the SHA of this particular star can now easily be found. You can see from this point, you can follow the laser pointer, from this point up to this point is 180 degrees. This is the angle between the observer's meridian and his inferior meridian. So this total angle is 180 degrees. The maroon color angle is 53 degree 36 minutes. So the green angle has to be 180 minus 53.36. That gives us the value of 126 degrees 24 minutes. So we get the SHA of this particular star. The SHA of the star is known. Now what we do is, you see we have this NX dash arc known to us. It is 13 degrees 08 minutes. We have the SX arc also known to us. It is 40 degree 20 minutes. And we are aware that from point S to Z is 90 degrees. Z to N is again 90 degrees. So this total N to S is 180 degrees. Now, if I subtract 1308 NX dash and SX 4020 from 180, I can get the diameter of this particular circle. So 180 minus 13 degree 08 minutes minus 40 degree 20 minutes gives me the diameter of this circle, which is XX dash. Now, if I divide the diameter by 2, I get the radius of this particular circle. The radius of this circle is px dash. Now, this radius of the circle which I am getting is basically the polar distance of the star. This is the pole, and point X or point X dash is the star. So px or px dash, both representing the radius of the circle.
Go ahead, beta.
सर ये 26 डिग्री 44 है, ये क्या है सर? ये px है वैल्यू, px की वैल्यू है ये
126.24 बेटा?
नहीं सर, ये 26 डिग्री 44 90 माइनस pd ये लिखा है आपने.
ओके, ये अभी आएगा बेटा.
अच्छा
ये अभी
सर,
आएगा.
आपने
ये
xx डैश की वैल्यू नहीं लिखी ना सर. xx डैश की वैल्यू कितनी आई है सर? 126 डिग्री 32 आएगी ना सर ये?
हाँ बेटा, तुम कैलकुलेट करो.
करा सर. 180 माइनस 40 डिग्री 20 माइनस 13 डिग्री 08.
राइट. हाउ मच इट इज?
सर 126 32 डिग्री.
वेरी गुड. अब डिवाइड बाय 2 करो.
इसको डिवाइड बाय 2 कर दिया तो सर ये आ गया 63 डिग्री 16.
वेरी गुड. ये
90 से
63 डिग्री
माइनस
16. हाँ, होल्ड ऑन.
ओके ठीक है सर, ठीक है सर, आ गया. डेक्लिनेशन आपने पहले देखी. ठीक है सर.
चले आगे.
हाँ जी चले सर.
ओके
सर, ये नीचे वाले स्टार के अगर डेक्लिनेट ये ले अपना SHA, ऊपर वाला स्टार लिया ना, मतलब है तो सेम स्टार, वहां भी तो ले सकते हैं.
राइट बेटा, नीचे वाले में नहीं ले सकते. इफ यू लुक इन द क्वेश्चन बेटा, उन्होंने ये जो LST हम दिया है ना, दिस वाज एट द टाइम ऑफ इवनिंग ट्वाइलाइट व्हेन द स्टार वाज एट x डैश. तो हम एरीज
सर, ये लिखा है
को.
वहां पे.
हाँ बेटा, मैं
यस 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 सर, यस यस यस. ओके ओके सर, पता लग गया.
ओके ओके ओके. मैं ये कंप्लीट करने के बाद आपको क्वेश्चन भी दोबारा दिखा दूंगा.
नहीं सर, वो समझ आ गया. वो LST शाम के दिया हुआ था जब ना, वो नहीं दिया हुआ था अल्टीट्यूड. ओके
राइट राइट राइट.
Right. Distance of the star. Now we know 90 minus polar distance gives us the declination of the star. So once we calculate px, you see this is the value of px here. We know pole to equinoctial is 90 degrees. So 90 minus px gives you the declination of the star, which in this case comes to be 26 degrees 44 minutes. So we get the declination of the star 2644. We get the SHA of the star, which is 126 degrees 24 minutes. With these two values, we can now go into the star information table on page 268, and we can look for this particular SHA. And from there, we find out that this particular star is Alpha, having this given SHA and declination.
So beta, any doubts in this now?
सर ये W WQE सर वो स्टार से नीचे सर कैसे सर एक बार प्लीज बताएंगे?
WQE स्टार से नीचे कैसे है बेटा?
यस सर स्टार से ऊपर भी हो सकता था।
ओके बेटा, हमने सबसे पहले तो स्टार का डेक्लिनेशन सर्कल निकाला था, द ग्रीन कलर सर्कल।
यस सर।
जो इक्विनॉक्शियल है, इट हैज टू बी पैरेलल टू द डेक्लिनेशन सर्कल. Equinoctial and all the declination circles are parallel to each other. So this WQE cannot cross this. Okay, it has to be parallel to this green circle, beta.
ओके सर।
Okay, this green circle is also centered at the pole and the equinoctial is also centered at the pole. So they have to be parallel to each other.
ओके सर।
Okay. और बेटा और कोई डाउट?
ये डिक्लिनेशन पीडी की तरफ।
हाँ बेटा, डेक्लिनेशन कैसे आया?
यस सर।
ओके बेटा, हमने सबसे पहले तो ग्रीन सर्कल का रेडियस निकाला, px और px डैश, राइट?
यस सर।
ये जो रेडियस है सर्कल का, ये है पोलर डिस्टेंस, बिकॉज सर्कल के सेंटर पे पोल है और एक्स पे स्टार है. सो वंस यू हैव द पोलर डिस्टेंस, यू कैन फाइंड द डेक्लिनेशन. इट इज 90 माइनस पोलर डिस्टेंस.
ओके थैंक यू
ओके
सर।
ओके. और बेटा और कोई डाउट?
सर एक डाउट था सर।
बोलो बेटा.
सर ये जो आपने सर ये ड्रॉ किया आपने 55 53 डिग्री 36 मिनट्स, सर एरीज होता है ऑब्जर्वर टू एरीज वेस्टर्ली,
राइट.
तो सर ये मेरे को ये इसमें डाउट है, आपने पोल के साथ कनेक्ट क्यों किया सर ये जो
ओके,
मेरिडियन ऑफ एरीज का है?
ये इसलिए कनेक्ट किया बेटा क्योंकि जो हमारा ऑब्जर्वर मेरिडियन है वो पोल से ही तो शुरू होता है. P to Z to Q to S. This is the observer's meridian.
करेक्ट सर।
और जो एरीज का सेलेस्टियल मेरिडियन है वो भी पोल से ही शुरू होता है. ऑल द सेलेस्टियल मेरिडियंस ओरिजिनेट फ्रॉम द पोल. और हमें इन्हीं दोनों के बीच में एंगल चाहिए था. सो दिस एंगल आल्सो विल बी मेड एट द पोल.
ओके सर, ठीक है।
ओके
ओके
ओके. So beta, this was one question. I have one lecture with you for tomorrow also. So I will show you some more questions on the rational horizon diagram. So for today, we will break off here, beta. So we will break off for lunch, and tomorrow I'll discuss a few more questions based on the rational horizon diagram and whatever doubts you have. So that we will do tomorrow. So let's call off this session. You can break off for lunch. See you guys tomorrow.
सर
हाँ बोलो बेटा.
सर ये व्हाट आर यूटीएम प्रोजेक्शन था क्वेश्चन सर. यूटीएम प्रोजेक्शंस क्या होती है सर?
ओके, यूनिवर्सल ट्रांसवर्स मर्केटर प्रोजेक्शंस. ये मैं आपको कल के लेक्चर में करवा दूंगा बेटा.
ओके सर. ओके
ओके ओके. ऑल राइट. सो see you guys tomorrow. Bye bye.
थैंक यू सर. थैंक यू.
थैंक यू सर। थैंक यू।
Thank you beta.